Alrighty, let's. I thought somebody was saying welcome or something, but let's just get started here. That was quite a surprise. Smallest screen I ever had, but I hope you can see it. If there's details you can't see, just speak up, please. Yes, my name is Soren Schroeder. I work for APC and Schneider Electric, and today we are obviously going to talk a little bit about virtualization and cloud, since that's the theme for today. But what I'll try to do here is kind of tie a knot back to the challenge that probably most of you will be living with, that you have an existing data center where this also needs to be living in. And there are a couple of challenges, let's put it that way, in doing it in a legacy data center as well. You know, only a few of us actually have the luxury of building a brand new data center for our virtualization or cloud journey. So before we really get started, there's just a little observation I'd like to share with you. When I joined university, probably some 20 years ago, I bought my first home computer. I remember it, an Olivetti SX16 with 4 megabyte of RAM, an astonishing 20 meg of hard drive, running Microsoft DOS 5.0 or something like that. And I remember the nice guy who sold it to me in the local office supply store there, he told me, "Soren, this is the best thing ever," and he took all my savings, by the way. "This is the best thing ever because this one is future-proof." Okay? It's future-proof. So you'll be using this one for the rest of your life, more or less. A couple of weeks later, I was struggling with the 20 megs, you know, and floppy drives and whatnot, trying to copy out documents and whatnot. Fast forward to today, present day, this weekend. I was, as always, it was bad weather in Denmark where I live. So I was indoor, walked into my living room, and there was my 2 lovely daughters, 6 and 9, both playing with each of their iPads, okay? Installing games, installing applications, playing games, surfing the web and whatnot, and all just, you know, the swipe of their hand, okay? So here they are, my kids, you know, 20 years after I bought my first PC, with more power in you know, portable in the palm of their hands than I had access to in the entire university back then. It's just amazing, isn't it? And the navigation, whew. Anybody ever thought about how much that looks like the Jedi trick from Star Wars? You will buy this device. You will use this device, okay? That was a little anecdote. So why am I telling you this? Well, I do go to a lot of these conferences. I do speak a lot of these conferences. And you know, everywhere we go, there's all this hype about cloud, virtualization, and whatnot. And absolutely, that's very, very interesting in present day. But what we also have to remember is that cloud and virtualization is not the end game either, okay? This is a step on the way to something different. So let's just accept the fact that whatever we do today will probably have to be undone or changed or whatever in 10 years from now. If we just look through, you know, high level the history of our, the evolution of our data centers, back from the big iron where IBM was dominating all of this, over the client-server revolution into internet revolution, where we all thought, you know, the bigger data centers we could build, the better, okay? 20% utilization for the best ones of them, congratulations. Into the age of maturity, where it was all about the modularity of our data centers and how quickly we could, you know, grow our data centers as demand rise. And now we talk about cloud computing, okay? So evolution has over time shown us that whatever we think is the best idea for today, you know, will probably change in a decade. So let's make very, very sure that whatever we do, you know, the investments we do have an outlook for the future as well. So let's just get this cloud thing defined, because we all think it's important and we all hear about it. I kind of like this definition by Forrester: a pool of abstracted, highly scalable and managed infrastructure capable of hosting in-customer applications and built by consumption. Fantastic little definition there, right? What happens if I take out the last 4 words here? And built by consumption. What have we just defined then? Anyone?
Utility.
Sorry?
Utility?
Well, partly. I'll say virtualization. So really, when we look at virtualization and cloud and the two together, let's think about it in a way, that's my suggestion at least, that what cloud really is virtualization with a twist. And that twist is the ability to actually build for whatever consumption we're utilizing, okay? And this is where I'll do my first, questioning of you guys, because I do talk to a lot of people that say, yes, I need my private cloud, or I need a public cloud, or whatever I need. And I'll challenge you, just think about, do you really need a cloud, or do you really need smart virtualized infrastructure? Just think about it, don't give me the answer. We can be here for a long time then. If you look at some of the value proposition for cloud computing from various vendors, and I've just blended it all in, I think it's actually very doable, isn't it? It's very appealing. We even got the word holistic approach in here, right? Everybody loves that word, holistic, because that, it's just so fluffy when we get it in there. It doesn't really mean anything. But really, when you look at it, and when you look what Cloud Computer does for us, it really enables us to deploy our applications, our business-critical applications, very easily, okay? Where else do we deploy applications very easily?
One small silly question.
Yes?
Why this cloud word has been used?
Why is?
Cloud computing. Why cloud?
Yeah?
Why not sun? Why not water?
Well, I don't think I'm the right one to answer that one, but...
I think it's a metaphor for these white things floating in the sky, and you just tap into it. So.
Well, it is a little fluffy, isn't it?
Yeah.
Okay. Thank you.
You're very welcome.
Well, good question. I never had that one before. No, so if you really think about it, deploying applications easily, well, that's kind of what we do on our computers, isn't it? If you look at a computer, like a modern one like this one probably is, all the complexity of the hard drive and the interoperability between and then the operating system on top it's really not a concern of ours, right? So really what I offer you, start thinking a little bit about, if you want to do cloud, think a little bit about data center as a computer where you deploy all of these things on. But let's just face a fact, 12%, that is the current all-size data centers across the world average utilization in data centers today. And when I say utilization, I mean, with all the stuff we put in, we get 12% out really, okay? On average, we only run 12%. That's actually up from 7-8% 5-10 years ago. So we're heading in the right direction, Soren, aren't we? Yes, we are. But again, there's probably 88% there that we could get more out of, okay? So why not look at this virtualization thing? Because it has a very, very promising value proposition, doesn't it? It's very hard to say no to any of these. Okay, no, I don't want less footprint. No, I don't want, cheaper labor cost. No, I don't want server deployments to be faster. Well, you don't really hear that, do you? So it's a very promising value proposition. And just facing the fact that 75% of all small, medium, and enterprises today have virtualization, according to IDC, have virtualization as their first choice when deploying new servers. Okay? 1, 2, 3. Oh, you missed it. Sorry. But really, that's what we have to think about. 3 out of 4 are already doing virtualization today, so something must be working here, okay? But what I just want to advise you here is just like anything else that has been brought into this world, it's not a silver bullet either, and it comes with a level of complexity. And what we'll do in the remains of this session is really examine, so what are these typical misunderstandings? Where are the pitfalls in virtualization rollouts? What is it that we don't think about when we look at this promising value proposition from a nice virtualization vendor? And let's just jump right into it. Virtualization is only the concern of the IT group. How many agree with this one? Little shake of hands? Let me rephrase it. How many handle virtualization rollouts as an IT project then? Probably most of you, okay? You don't have to answer, that's fine. But really, you are kind of wrong here, because what happens is whatever you do in your data center, whatever you bring into your data center will have an impact on something else. And just handling this as an IT project is probably, I'm not saying likely, but there is a chance that this will set yourself up for a disaster here. Let me just explain why I think that. Well, it's really the same stack and the same number of people or groups or entities inside our organization that we have in play to actually deploy virtualization. We still have at least these 2 groups. Let's, for the simplicity of them today, call one of them facility. This is where we have the power, the utility, the cooling loops, and all of those mechanicals handled. And the other group, we can call them IT. I know they're typically split into more groups depending on company size and all that. But let's just call them IT for now, handling the rest of it. So these 2 groups have to really cooperate, and that has not really changed just because we call it virtualization. This is just a way of breaking out that stack. of things to actually deploy to actually get the virtualization value proposition to work. At the bottom, utility building data center infrastructure. Okay, so far so good. We feel pretty comfortable here. On top of that, the bare metal hardware, we put the hypervisor, that's the mini OS that enables the virtual machines to run on the bare hardware, the virtual machines themselves, and the applications. And all of this we do just to provide business value. Okay? That's actually quite a stack to deploy to actually get that business value. And please keep in mind, the business value is why we're doing this. It's not just to have fun and find the new coolest technology. It's really to provide that business value. Typically, we put a line here. We call everything below it supply. We typically nominate the facility team to take care of that. Okay? Don't tell us how you do it. Just take care of it, please. Everything above we call demand, and we let the IT team rule in this world. We give the IT team a little tool that we call virtualization management. Good vendors like VMware, Microsoft, and others have done a great contribution to the industry to actually get good, solid tools into managing this part. The rest of us are fighting down here with tools we call DCIM, or Data Center Infrastructure Management. These are similar tools that just takes care of the physical infrastructure. What has happened over time, with Schneider as the leader in this game, of course, is that we have started looking at the IT hardware as well, as part of our physical infrastructure observation, if you will. So what we can really do now is, first of all, we have some overlap between the two, but secondly, now we can start pushing up the line here, okay? We can even be really cocky and put it all the way up at the top here. Why would we do that? Why would that be interesting? Sorry, to get it all the way up there. Why would that be interesting? What is that really?
Control.
That's really the definition of cloud, isn't it? Okay? Everything below is the supply side of our cloud equation, and everything above is our demand we put on the applications. Okay? So when we implement cloud, really what we're doing, we're basically just pushing the supply-demand line upwards, so to speak. But that also puts a little bit more pressure on us, because now the teams below here have to cooperate to deliver, this supply equation, if you will. Let's move on. This one I hear a lot. Virtual machines are free. Hey, Soren, I already paid for the data center. I already paid for all the servers I put in there. I can start as many as few virtual machines as I would like to. It doesn't change anything. It's free for me. How many think that? No, you don't have to answer. You are wrong if you answered yes to that one. Because as minimum, there will be a cost of energy associated with that. There might be several other costs as well, but there will as minimum be a cost of energy associated. And this is why. When you have servers that you deploy as host servers for your virtualization, the first thing you do is to switch them on. Now the idle power that your server is consuming is already 50% approximately of the total power that server could probably consume. I'm not talking about the nameplate from the vendors. I'm talking about what it actually, worst case, could consume in terms of power. But 50%, somewhere between 40 and 60 actually, is what you spend already when you switch on the server. Then for every single one of the VMs that you kick off, that you start on that host server, you add a little percentage, again depending on the make and model, you add on a little percentage to that idle, meaning over time you're actually upping the idle power draw on that server. Okay, so even though these virtual machines are doing absolutely nothing for you, just sitting idle waiting for that once a year job to run, it's actually consuming power. Okay, this is what we call virtualization sprawl. For those of you who in their past life or current life is fighting the fact that somewhere between 20, 30, maybe up to 60% of all servers that we have in our current data centers are doing absolutely nothing, because they were introduced at some point by somebody that forgot about them or left the company. Somebody at least is nodding. The same thing is now happening in the virtualization world, okay? It is becoming even worse, because it's so freaking easy to just kick off a new virtual machine. Just ask IT to do it, and boom, 10 minutes later you have a new machine, a new server that you can utilize. But again, who controls if these VMs are ever used? Who controls if we're actually getting any benefit out of that virtualization sprawl? Who determines if power and cooling requirements are still met? Yeah, but Soren, I set up my data center in a way that every single server can run at 100% at all time. Power and cooling are good. Okay, good for you, but that's a very expensive approach. Maybe you want to rethink it. So every VM does consume power, and some average numbers for you, just to set this in perspective. Every kW that you put in your data center costs between 10 and 15k pounds to build and 1,000 pounds to run each year. Just put that in perspective. So those little percentages that you could just keep adding on to every single server, it actually sums up. It becomes quite expensive for you. Number 3, and this is the biggest one. My VM management software helps me optimize my energy usage. This is one I've heard a lot, to be honest. And I understand fully why people think this way. Because again, remember what we're doing. We're typically going from maybe hundreds of servers down to fewer. Okay, maybe a 10 to 1, a 10 to 8 or whatever, downscaling of the number of servers. So obviously there will be an energy saving there. But what also happens is that your VM management software solely focusing on balancing the IT resources in that equation, the CPU, the memory, and the storage. So what you're caught in is basically this, what I call the virtualization jigsaw. Okay? On one side, you have your virtualization management solely focusing on CPU, storage, and memory, because that's what it understands. It goes down to the server level, if you will. On the other side, you have your other things that you're trying to accomplish, like your energy costs, your data center capacities as a whole, and really balancing those two is where many of you will probably be stuck in this. Or maybe you'll just ignore it and you'll hope for whatever reduction you get out of this is enough. I'm giving you a graph here, and I would really love some guesses. What is this graph showing you? I know I haven't put anything on the y-axis there. Any guesses?
Rainfall in April.
Sorry? Rainfall in April. It must be UK then, yeah. Oh, maybe if I put this one on, it helps a little bit. Now you have no clue, and why would you? Because I'm totally changing the subject. Now this is the fuel consumption of my Volkswagen Passat 2011 Blue Motion. Okay? What you can clearly see here is that I'm averaging just below 16 kilometers per liter. You can clearly see the weeks where I've been traveling, whether my wife is driving, and you can clearly see the weeks where I was in Germany just driving it at the Autobahn. So why am I showing you this? Well, this car, being a Blue Motion, it's a very energy efficient car. Actually, from factory, it's rated at 21.7 kilometers per hour. 21.7 kilometers per liter. So why am I only doing 16? I'm doing normal driving, okay? At least I suppose I am. And what I'm trying to tell you here is, okay, point-in-time measurements, which really is what we are getting from the factories in terms of the normal driving conditions for a car. I can get it above 20, absolutely. I just have to drive like a very old man. And I will, sorry, no offense to anybody, by the way. And I probably can get it up to like 20, or 21 maybe even. But that's not my normal operating condition, okay? And why I'm telling you this is there is a figure that we keep using in the industry today to kind of rate our energy usage and how much energy we are putting into our data centers and how much we're getting out of it. Virtualization or not. It's called PUE. Is everybody familiar with it? Power Usage Effectiveness. It's an index value telling us how much of the total energy actually ends up in our servers and thereby contribute to the IT equation. PUE is one of those very misunderstood figures, if you ask me. Saw some claims last week, I think it was, from the US, claiming now we have a PUE of 1.012. Well, good for you. How did you measure that? Well, it was a point-in-time measure under really ideal conditions. And by the way, we left out half of the things that we normally put in the equation. Well, fantastic. Then everybody can get a good PUE, okay? So what I'm just want to advise you here is, PUE is a good metric if you use it right. And one of the things I'll just walk you through here is now, how can you figure out whether or not your virtualization, your cloud endeavor, is actually helping you from an energy point of view? So let me give you a little case study here. This is a North American data center running around 1 megawatt, 70% loaded, no redundancy, with a PUE around 2.0. Power usage effectiveness. It's basically a metric indicating how much of the total power ends up in the IT equipment, and thereby how much is lost everywhere else. So 1 is the ideal, okay? And getting to 1 is very difficult, actually impossible. Okay, so now we have a data center, that's our foundation, okay? So now we want to start virtualizing in this data center, and we actually virtualize with a very aggressive 10 to 1 server reduction, okay? What that gives us, it gives us, we went from just below 1.5 million US in pure energy cost per year down to 1.2, actually a 17% reduction. Fantastic. So we did good. Okay, we did good. We just reduced energy by almost $300,000 for a year. But at the same time, our PUE went up. How come? Well, very, very simple, because the supporting infrastructure remains the same. Thereby, a lot of the energy that we potentially could have saved is now just wasted in our cooling loop or our UPS loop or our mechanical loop or whatever. So what we really should do, and by the way, all of this is described in our white paper 118 that you can go download from our website if you want to. It's free of charge. What you could do here is you could right size your equipment to actually fit the new situation in your data center. If you do that for this specific data center, you're actually down just below 900K US after you have reduced the cooling and power loops, if you will. So what you're actually doing here is that totally actually you get a 40% reduction here. If you just virtualize, you will actually have a savings, absolutely, but at the same time you made your energy equation worse. If you improve your energy equation, you will actually have a bigger saving. So the bigger part of the saving is really not in the virtualization effort itself, it's in right-sizing the infrastructure around it. Let's take another study, and this one will be a little bit more tricky. What we'll do here, we'll try to do a backwards calculation, saying we have a data center, 45 racks, 10 kW. That's a pretty awesome data center by today's standard. To run that data center, when we take all the typical losses we have all the way from our energy through the transmission, etc., we actually need an equivalent of 2.5 megawatt just to run that 450 watt data center. Kilowatts, sorry. So the way to read this one is, with every step here, what is the requirement for the next step? Okay, so you can see we have a big loss here on the fuel efficiency around the power station, little losses on the transmission, and big losses in the DC. Actually, if we do the backwards calculation, these are pretty simple calculations actually, we end up with spending almost 13,500 barrels of oil equivalents. So we need to pull a lot of oil out of the ground to just support, and that's on a yearly basis by the way, to support this awesome data center. Yeah, but Soren, I'm just going for wind or solar or whatever, and then that's solved. Yes, absolutely, good for you. But let's just face the fact that most of our data centers today are still run on energy coming from oil or coal. Okay, so this is very, very real. This little calculation I did here for you is actually assuming a pretty bad PUE of 2.5. So what happens if we actually improve that PUE? Well, let's first look at what we can do. We can't really do anything here, right? Fuel efficiency, that's not our business. Transmission and transformer is not our business. Well, it's Schneider's business, by the way, but it's not your business. So where you can do something is really around the data center infrastructure. So let's try to do that, and let's just observe what actually happens as you improve that PUE over time, that usage of your energy inside your data center. Just notice, I'm still running the same data center, the same amount of servers. I'm not changing anything in the servers and processor level. I'm only changing the physical infrastructure. And just look, we more than halved the number of barrels of oil equivalents that we need to pull out of the ground to actually operate the same data center, just because we're doing it on better, smarter infrastructure. That's the feel-good slide, by the way. We can feel good about it now, okay? Just improve the PUE and we're all good. So what happens if we start looking down here and screwing around down here and actually virtualizing some of these servers and thereby reducing the number of servers? Well, if we do it without looking at the infrastructure, right-sizing the infrastructure, we know from the previous slide here that we will make the PUE worse and thereby we'll drive up again. So what we could do, we could stay at the same and just, accept the fact, and this is just a very simple reduction, 20% down to 8 kW per rack. And now we even further deduct the number of barrels of oil that we need to pull out of the ground. So again, if we do it right, if we do our virtualization right, yes, we will save energy. If we do our virtualization wrong, we will actually end up in the wrong direction again. That's something to think about, okay? So it's time to take off the blindfolds and start bridging the gap between facility and IT, because that's really where this complexity is. IT is doing their good work on the virtualization, but we need facility to follow on the physical infrastructure. This is typically what happens in most organizations, and I'm just assuming many of your organizations will probably be quite similar to this. You will have a facility team on one side. The facility team will have isolated systems, siloed systems, that all have been put in with good intentions in mind, by the way, and they all have their purpose in life. You have the same on IT, and here you have your virtualization management is just one of them, one of the many siloed systems that we have on the IT side. Actually, in the IT side, we're probably a little better at integrating wherever we can. But what really happens is we have siloed systems on IT, we have siloed systems on facility. Nothing is typically shared between the two groups unless we're really, really forced to, with our hands on the bag and all that. So really, the situation that we have at hand is very much this one. Does anybody know this story? The blind man and the elephant?
Yeah.
Oh yeah, our guy from Nepal is laughing. It's from your neck of the woods. So this is, or the blindfolded man and the elephant is the more, political correct version now. So this is the story. Does everybody know it? Or do you need the poetry lesson here? Because we can go through that. There were 6 men of Hindustan who learned much inclined, who went to see the elephant, though all of them were blind, that each by observation might satisfy his mind. Okay, so they all walked up and want to touch this elephant, but since none of them could touch it, or none of them could see it, they all got a different perspective. And there's 6 courses about, what happened then. And then the conclusion here. And so these men of Hindustan disputed loud and long, each in their own opinion exceeded stiff and strong, though each was partly in the right, and all were in the wrong. So what do we just learn here? Sorry for the poetry lesson, but I just love this stuff. What do we learn here? If we have these people that are all blindfolded because they are all looking only at their own systems, they might reach conclusions and they might tell you that this is the absolute truth to whatever problem we have. But if they don't know what else is around them, they could be very wrong in their observation. Okay? So what's the conclusion? What's the necessity here? Well, let's just make it a little bit more complex. And let's add this parameter to it. We have too much data today. Okay? I'm just figuring most of you will have the same struggles here. The section here is actually from a conference in Saudi Arabia that I'm going to participate in very shortly. Where most of day 1 tracks is all about big data. Because data is being aggregated. Data is being consumed from so many sources today that we just, it's becoming, impossible to make sense of it without good systems. Mr. Singh here is the EMEA champion for the Green Grid, and like his little story here, is one of the guys I follow on Twitter. I can advise following him. He has some very good tweets there. 1.5 billion data points over a month in eBay's new Phoenix data center. Oh my God, that's a lot of information. How would you keep track of it? How would you turn that information into knowledge without really something to help you there? And this guy Jan Wismer from Netherlands, he's, I'll let that speak for itself. I don't think he's too satisfied with his vendors there. So really, what's the problem here? Well, the problem back to this is really we have so many siloed systems. We have so much information in each of these siloed systems. And what we really need here, we need something that can span those many systems, not take all the information in, but take key information in and translate that from information into knowledge in what we call a context-aware model. So this model really understands what a data center is, what the complexity is, all the systems that needs to run there, what's the dependency between all the systems, etc., and pulls that information out of the various systems where it's applicable. So really what happens, let me just give you an example here, back again to virtualization. So really talking about, how this system operates with the DCIM system here. Well, remember this stack, there was the virtualization at the top, there was the DCIM at the bottom, and now these two systems need to work together. So let's see how that works out in reality. And let's start by meeting our VM operator. Let's call him Bob. So Bob is the happy user of the virtualization management. In there, he is typically looking at CPU, memory, and storage, because that's the 3 parameters that he can see inside his virtualization console. He can also see how each of the virtualized jobs are allocated to various servers, and he can probably move around virtual servers as he sees fit. Bob is now also the happy user of a DCIM solution in which all the cooling, power, network, and space requirements plus more has been allocated and gathered. But what Bob sees, he doesn't really work with the DCIM solution. He keeps working in his own solution. his virtualization management. But what he gets by having these things available to him transparently in his current console is things like server placement, server health. So he don't move a virtual job to a server that's really not healthy for it. If there's any power capping, if we, through peak hours have the necessity to just, throttle down some of the servers just to keep, below the radar on our power requirement, well, then he can see those things. Power and cooling dependency, so he doesn't, again, screw himself up. And if there's events in the physical infrastructure that will impact his virtualization, hence his cloud operation, he can see that as well. So what we're really doing to Bob, as an IT man, we're making him facility aware, okay? We're not really teaching him everything about the mechanics and the cooling and the fluids and all that of the data center, but we are helping him understand the impact it will have on his IT operation. So let's meet his counterpart. Let's call him John for today. So John is the facility manager. John is responsible for all the power and the cooling and all that good stuff. So John is obviously the happy user of a DCIM in which he expresses all the concerns he has for power, cooling, space, network, and all the rest of the parameters that might be limiting him in his operation. John is by no means a user of the virtualization console. He probably doesn't know what it is. If he can spell it, he'll be lucky. But what John gets by integrating the two is that he gets a set of information back, like what's the actual power draw in this? What's actually going on in there? Is there any allocations I need to be aware of that could be dangerous? Because what typically happens here between the two is that from time to time they have a little discussion about especially cooling and power capacities. I don't have enough power. I need more power. Can you buy me some more power? Well, what do you need it for? Well, I need these 10 new servers to host my new virtualization. Well, guess what? You have 50 servers running idle, doing absolutely nothing. Maybe you should take a look at those and retire those before you actually, start. So really, getting away from the ridiculous investments in just, blindly buying new capacities without really looking at what's already at present and what's not utilized. So again, what we're doing to John here, we're making him, as a facility manager, facility guy, we're making him IT aware. Again, without sparing him for all the details, but really giving him enough information for him to operate at his prime. So really what happens here is that DCIM becomes the centerpiece for these different groups and systems. You keep your IT systems, you keep your facility systems, but you tie them together, and what you get out of that is you get things like you can do simulations, you can do capacity planning recently, you can do analytics on top of your various setups, etc. So again, whatever is about to happen in here, you can simulate and you can get the answers before it actually becomes a problem. And by the way, you can probably add some more information if you get a full-featured solution like the one Schneider offer you. This is where you can get temperature sensors and whatnot in there as well, so that again, you operate this at its prime. So, 3 things to walk away with here, and I made it in time for the 2 o'clock, I know that, so there's plenty of time for questionings. Don't do your virtualization projects in isolation, okay? This is not just an IT thing, it actually has an impact on the entire organization, so make sure you are talking to your counterpart on your IT side if you're a facility and vice versa. Fight virtualization sprawl, just like you fight, the endless number of servers sitting out there in your data centers that does absolutely nothing. Make sure you stay on top of that. That means good processes for approval of getting new virtual servers kicked off, but it also means good tools that can tell you whenever virtualization engines are running idle and really not contributing to the business value. And then the last one, continuously right-size your physical infrastructure as you grow or shrink your server load demand. And this is the hard part, I know. If you're living in a existing data center that might have 10 years operation on its back already, that might be the hard part because it might not be as easy to just scale up and down that infrastructure. Modularized infrastructure components is obviously one answer to that, but again, it's something you need to consider. I have a little giveaway for you today. If you run by our booth, we have this lovely 90-day trial of these software applications, or a specific version of it where you can actually validate the 3D airflow inside your data center if you're interested. That was it. I'm now very open for questions, should there be any.